Toro Commercial products are becoming electrically more complex. The use of multiple controllers on a machine can make troubleshooting more difficult as we try to monitor all the inputs and outputs from these multiple controllers. While Toro Diag is a good diagnostic tool, we can only view the input and outputs on separate tabs for each individual controller. This is okay when needing to check for input or output signals from a single controller. The issue arises if you want to view inputs or outputs or a combination from two controllers at the same time. This becomes very difficult with Toro Diag. To overcome this issue and to help more effectively troubleshoot electrical problems, we are pleased to announce a new diagnostic software tool called ToroScope. So what is ToroScope? ToroScope is a software diagnostic program that provides real-time graphical display of the input and output signals from the machine's tech controller. This will allow you to see any combination of the tech controller input and output signals to help in diagnosing electrical issues. ToroScope is a type of digital storage scope that does not use probes like an automotive digital storage scope. Rather, it connects to the machine's tech controller via the same diagnostic cable used for Toro Diag. ToroScope is now available in the Toro Diagnostic Distributor folder, starting with Toro Diag revision 1.3.12.0. To get to ToroScope, navigate to your Start menu, scroll to All Programs, then scroll down to the Toro Diagnostic Distributor file. Once in that file, you will find ToroScope. If you do not find it, then go up and select Check for Updates to update your Toro Diag software to the latest revision. So let's open up ToroScope and take a look around. Once ToroScope is connected to the machine and the ignition key on, the software automatically connects to the tech controllers and determines all the available inputs and outputs. ToroScope makes viewing multiple signals much easier, as you can view up to 8 digital input or outputs and 2 analog type inputs or outputs, or PWM output signals at the same time. The signals are then displayed in this area to the right. To choose the input and output signals, select the Edit menu and then select Signals. All the inputs and outputs that are available for the machine you are connected to will be available in the following tabs. There are digital inputs and digital outputs. These are the binary or on or off type signals. Analog inputs are signals that vary over time. Current outputs are a type of analog signal. The set point is what the controller is commanding, and the value is the feedback of the actual current signal applied to the circuit. PWM, or pulse width modulation, is a type of digital signal that varies the voltage by changing the frequency of the on to off time. Sensors are the analog inputs from resistive type sensors like a fuel level sensor or a hydraulic temperature sensor. And lastly, any engine faults, or SPNs, are those engine faults that are available on the CAN bus and can be displayed using ToroScope. So let's look at a few examples of how we can use ToroScope. Here's an example of an RM5410 reel circuit. And so we're going to do cutting units lower. And so for my inputs, I'm looking at joystick up, joystick down. I'm looking at deck down sensors, the SVRV, SV1, SV2, SV3 for controlling the reels up and down, and then a PTO circuit in the analog section. The trace starts by a joystick down input. You can see SVRV and the SV1 energized to allow the lowering of the cutting unit. When the lift arm passes the deck down switch, an input occurs which commands the reel motors on. From the analog trace on the bottom, we can see the set point, the green line, and the actual value feedback, the red line, of the signal to the PTO circuit to energize the reels. Next, there is a joystick up command. The lift circuit is energized. SVRV, SV1, and SV2 are used to lift the front decks, and they start to raise. The front reels shut off, as we can see from the analog trace at the bottom. Next, we see SV3 for the rear reels lift energize, and they start to rise. The front lift arms hit the deck down sensor, and it changes state, which we can now see. And now SV1, which controls the front lift, de-energizes, and the front cutting units stop at the turnaround position. So, From this trace, we can watch the complete sequence: the joystick commands, the solenoids activating the raise lower, deck down switch, the analog at the bottom for engaging the PTO circuit. If the reels were not physically lowering or the reels were not engaging, we would know that from the controller point of view, which we've just looked at, the electrical circuit is working properly. So now that would mean we'd have to go and start looking mechanically, either in hydraulic circuit or a valve connection. Hopefully you can see graphically how ToroScope can provide a lot of information in a picture to help tell a story to help us in our troubleshooting. Where ToroScope really shines is in displaying analog signals. These are signals that change over time, like a traction potentiometer or a PWM signal to operate a solenoid. This next example is watching the PTO circuit engage the decks on a GM4500. The GM4500 uses a pulse width modulated or PWM signal to soft start the decks. The top line is the input signal from the PTO switch. In the analog section, we can view the current set point and the actual current feedback to the PTO solenoid coil. The green line is the current set point to the coil. You can see the controller intent of ramping the current to the PTO solenoid coil to soft start the decks. The red line shows the feedback from the actual current value applied to the coil. You will notice that we do not mirror the set points exactly, and the reason for this is that the data that's being provided comes over the CAN bus. There is a priority in what data is sent, and this may cause a slight delay as the data is updated. But we can see that the current value is rising over time, and the trace is a good representative sample of what the current is going to the coil. From this graph, we can view the PTO switch changing state from off to on to off. We see the controller's intended current signal and the actual current feedback. Hopefully, you can start to see how much information is presented by these three traces and how we can interpret them to understand what's happening with our circuit. In this case, if the decks were not engaging, but we see the current, or the red line, increasing, we know electrically the coil is getting the current signal, and the issue would be something either hydraulically or possibly mechanically in the cartridge valve itself. The last example is a traction circuit used on a GM5900. Again, ToroScope is very good at displaying analog signals. So when trying to troubleshoot a traction control circuit or drive-by-wire, we need to know if the control, or in this case the traction potentiometer, is commanding a traction signal to the tech controller, and then that the tech controller is commanding a signal to the servo in the hydrostat to move the machine. The top trace shows the input from the forward neutral switch, and the green analog trace is the intended current set point from the traction potentiometer, and the red trace is the actual current or the feedback signal from the traction potentiometer. Again, the traces are not exactly mirrored because there's some delay in the feedback current information delivered from the CAN bus. The important thing to notice is that there is a set point value, and the actual current feedback value is closely mimicking that set point, indicating the potentiometer is working as the traction pedal is moved. On this last trace, we see the red line trace as the analog signal to the hydrostat servo solenoid, and the green line is the analog signal from the traction pedal to the tech controller. In this trace, we're able to see that the traction pedal is moved. There is a corresponding signal from the tech controller to the hydrostat. Again, the traces help to paint a story that at a glance is very easy to determine what is happening with our traction circuit. There is a new section in the Toro Diag User's Guide that covers in detail all the menus and features of ToroScope. I recommend that you check that out and then give ToroScope a try. There will be online training modules coming out in the near future that will go into more detail on the features and menus of using ToroScope. Contact Toro Commercial Customer Care with any comments or questions regarding ToroScope.